Good morning, all of you. Only 6, 7 students are present. Let them. We will wait for again 5 minutes to join them. Okay. So just for wait for 5 minutes. ये लेक्चर अभी अभी चल रहा है। Okay, dear all students, only 23 students are present out of 160 or 160 plus. So why the students are not joining? Okay, anyhow, uh, we will start. So dear student, yesterday we have started the unit number third, that is instruction set architecture. Okay. So dear students, please respond to me. Am I audible? Anyone, please, you can respond me. Am I audible? Dear student, am I audible? Please respond me. Anyone? Hello. Hello, dear student. Am I audible? Hello, dear students. Am I audible?
Yes, sir.
Okay. Okay. At least you respond me, no, to continue. First of all, very less students are there. Again, you are not responding. It's fine. So, dear all students, yesterday already I started third unit of computer organization and architecture. So that third unit is instruction set architecture. So as per syllabus, we will check with the syllabus. Uh, just a minute. that is organization. Okay, so here this is the computer organization and architecture. In that, the first unit and second unit clearly we have studied. So in this, now I am started with your as per your syllabus, that is third unit. Got some messages. So today we have to start this third unit, that is the instruction set architecture and the memory. So dear students, due to NAC committee is going on in our institute, today just I have to take half an hour because students also very less, because I want to join with the committee, NAC committee. So just half an hour I have to conduct, and in that bit of the parts I have to explain you. Okay. So again, many we will continue with the next lecture. So here in the unit number 3, that is instruction set architecture and the memory. At the first, we are going to observe that instruction set architecture. Okay, so in that hardware components of the instruction set architecture, we'll go through that. And all RISC computers, we will go through it. Pseudo operations or synthetic instructions, examples of assembly language programs, as accessing data in the memory addressing modes, the memory hierarchy, cache memory. This is entire the syllabus of this unit. Okay. So already bit of the things I started yesterday, because of again the activity will not take too much. So today also same thing. I have to cover just for 20 minutes. So here that is the instruction set, unit number 3. So in that, uh, so here unit number 3, just for 5 hours chapter, that is the topics of unit number 3. So in that we will see that the hardware components of instruction set architecture. So as per hardware components of instruction set architecture, as the first point, that is with the main hardware components of architecture, that is by system bus model. So in the system bus model, there are mainly three main buses are there: data bus, address bus, and control bus. So that one we say it is a system bus. So in these buses, they are acting along with CPU, ALU, register, and control. One part, and second part, that is the memory. Third part, that is the input and output. So here in the CPU is what? That is central processing unit, and ALU means algebraic logical units, which is the functionality inside the central processing unit, along with some register side control units. Okay, and here memory, wherever the data we have to store, that is called as memory. So the data is manipulation between it means that transfer between one place to another place, or memory to input and output devices, or memory to CPU. For that we are using the different buses. Again for the same thing, input and outputs. So many of the inputs we have to use, and output also we have to use. For example, or printer, scanner, monitor, keyboard, all are there. So all these functionality we are going to be handled by using the system bus. So in the system bus, there are three types of buses. Data bus. So data bus is always in the bidirectional one. That is, data is to and fro movement. The data bus will what it will do? The information is transferred between to and fro direction. So that's what it is a bi-directional one. And address bus, control bus, these are control bus is also a watching in a direction, and address bus is also a in a direction. So what the address bus will do? It will find the address means where the data is going to be sent, and what the control bus will do? The control bus is just to control the flow of the data between source and destination, and the data bus is nothing but the information whatever you have to study the data to the destination point of. Okay, so this is the hardware components of instruction set architecture in the instruction sets. So yeah, all the instructions we are going to be transferred by using this concept. So next one, as you know, that is the memory. In the memory, bit is having a 0 bit. Nibble means 4 bits. 4 bit is equal to 1 nibble, and 1 byte is equal to 8 bits. 1 byte is equal to 8 bits. 16-bit word hardware, and 32-bit, 64-bit, 128-bit, 256. Like that, the memory is going to be arranged in a manner. Memory is going to be arranged in a such a manner, and here the hardware components of instructions, along with that, two main formats we are using: big Indian format and little Indian format. So here in the big Indian format, so we have to uh, take the values of from lesser value to the more value up to the byte to the size. So here this one we called it as the MSB, most significant bit, and this one is the least significant bit. So here, what we are using in the big Indian and what we are using in the little Indian, and also we are going to be find the difference between these two. So in the big Indian, the data is from lower value to the higher value, and in the little Indian format, the data is from higher value to the lower value with the multiples of a number of values. That's what we have to take it here in the big Indian and little Indians. Okay. So after that, we have to think about the memory map with the architecture. So in the memory map with the architecture, that is, say this is the one chip of memory. That memory chip is having a data input and data output. So this is the portion of data output where the data is going to be delivered it, and this is the portion of input where the raw material of input is given to the memory for the storage purpose. So in that storage purpose, that is data in is here, data control and address bus. All these we have to use it. So whatever this memory chip is there, that cross-sectional portion I have to show it here. So entire 32 bits capacity, and which is having an address of 0 to 2 raised to 12 minus 4. You have to count it. 0 to 2 raised to 12 minus 4. So this is the size of address is containing this memory. So in that, at the first portion, there is a reserved for operating system. So from the operating system, all the data manipulation is going to be operated it, and that is from 0 to 2048. And here some user spaces is used. User is going to be work for on this memory, and some unused space is also there. For the further usage, future usage, we have to use some total unused space, that is for future usage. So again, we are using in the memory, that is stack pointer. Stack pointer is for to store the data first in, last out, or last in, first out manner. So that is the portion is also present in this memory. And here for the input and output spaces. So to do the manipulation to sending the data and to retrieve the data or to fetch the data, that is input and output spaces are there. That is disk terminal pointers. We have to say these are disk terminal pointers. So that is total size of this address is 0 to 2 raised to 12 minus 4, which is byte, and 2 raised to 12 minus 1 is there. Okay. So this is the memory, just one cross sectional memory I am showing you. This memory is internal structure is this one, isn't it? So next one, we are going for memory map with arc architecture. So as we know, the van Neumann architecture of the computer. The van Neumann architecture of the computer is basically containing three main functional units, that is control unit, algebraic and logical unit, and one more is registers, or we have to say memory, or even we have to say storage space, storage element, nothing but the registers. So in this high level view of CPU, these main three controller units are there, that is control unit, registers, and ALU. So the registers and ALU, this one we say it as a data path, data section, and this control unit we say it is a control section. So entire this system which is control the all the flow of data between algebraic and logical units and the registers. Okay, so this is our memory map with our architecture. So here next one, memory map with architecture, that is with the data path. As you know here, this one is the data path and this is the control section. So first one we will see that data path. So in the data path, how the data is transferred from register to ALU, from register to algebraic and logical units. So here in the data from data bus, register file is there. In that register file, all the data is present, and that data is going to be transferred to the address bus and data bus. And here there is algebraic and logical unit. So what it will do, all the logical things should be going to be happen. So to this address where the data is going to be transferred to address bus and to data bus. So data bus and address bus, what it will do, data bus is the thing, but that is the containing of the information or a data, and address bus it is going to be where the data is going to reach, that one is find out. And here in this register file, it will control unit is also there. That control unit address register and ALU functionality should be there here. Okay. So next one, that is status to control units, that is for controlling purpose, and register destination to viewers, whichever is not controlled. Again given to the register file. Again the process is cycle is repeating from data bus to data that controlling. Okay, so this is the algebraic and logical unit. So this is the data path between register file and the algebraic and logical units. Okay, so this is the very important one, register source 1, register source 2, register source 3, n number of registers you can use for the storage of data, and there is the path between register and the ALU, that is for data bus and data control. Okay, address bus and data control. If the whichever is not controlled under this, that one is going to give feedback to register file. So this is the data path for the example. So next one, I am showing you some registers, because everywhere we are using that register, right? So what is exactly register? So these are the visible registers in the R machine, and the registers we are going to be arranged in a serially and sequence manner from 0 to up to 31, because our this capacity is 31. Okay, this capacity is 0 to 31 for 32 bits. So that's what this is, the 32-bit capacity. Register 00, register 01, register 02, register 03, register 04, like that up to register 31. So in this we have to represented that percentage R1, means that register R1, register R2 up to register 31. That is R31, percentage of for 31. So here this is the PSR and PC program counter, program special register and program counter, that is of the 32 bits. So all these registers are arranged here. In these kind of registers, the data is going to be maintained, or the data is going to be stored in it. Okay. So these are the different registers for the storage purpose. So after that, uh, with the memory architecture of ARC, there is a used for the instruction set. So in this main instruction set, we are using data moment, arithmetic and logical instructions. Data moment is what? Just for to transfer the data from source to the destination, or to destination to the source. So that is nothing but a data moment. And arithmetic and logical instructions. So in that arithmetic, already all the arithmetic operations you have to study, and this arithmetic and logical instructions also you studied in the microprocessor. Same arithmetic and logical instructions again we are going to be repeating this. And the next one is control instructions. Also we have studied, that is jump instructions, loop instructions. These are the control instructions. And some virtual machines, some extra usage of memory, temporarily work execution. We are using the virtual machines also, that is for the instruction set purpose. And in the architecture, that is second type with software for generating machine language program. So in that generating machine language programs, we are using compiler, assembler, load model, and runtime. Runtimes are nothing but what? At the execution time. So compiler, as you know, always it is compared to high level language to low level language, and assembly language low level language to machine understandable language, and load model. So whatever the code we are preparing, we have to load on into the model. And finally load model is nothing but debugging. Okay, debug. And finally that is runtime. So in the runtime, it is the execution time, how the program is going to be executed, that is runtime. So next one, here some ARC and sys computers are using memory registers. See, registers and memory all are same, but when we have to say memory, memory is nothing but the bunch of registers. Okay, many registers including a, we call it as memory. And assembly language formats, it is using in the ARC symbol. And arithmetic and logical instructions, load and store instructions, and control transfer instructions. So all these instructions already we studied in the microprocessor, but here in the organization, that is should be computer organization. Again, we are using, we have to explain all these instructions. What are those? That is arithmetic and logic instructions, that is load and store instructions, that is control transfer instructions. Okay. So again, one more, that is in the instruction set with the data moment instructions. Again, there are different categories in the data moment instructions. Those are arithmetic and logical instructions, shifting instructions. Okay, shifting also we have studied. Right shift, left shift, right shift with carry, left shift without carry, with carry. All those 6 to 7 categories also we have studied. So just we have to use this instruction set concepts. Okay. So after that, so this is the instruction set format what we are using in the computer organization. Just for your understand the purpose, I have to make it as, that is one format, branch format, we call it as call format, we call it as arithmetic formats, and memory formats. So different just memory. How these formats are arranged inside a internal structure of a memory. That is the one diagram I have to show you. So this is the thing today what I am going to explain you. Okay. So just dear all students, you go through it. Only 32 students are there. It's a very bad about the attendance. Out of 160, more than 160, only 32 students are present. But I don't know why you are not attending the lecture. So here, this is the thing. I am going to, yeah, just I'll take the attendance before leaving up. And next class onwards, we have to take a action on you, because if attendance is very less, then it's very difficult to handle it. So just for 1 second, I have to take the attendance of all of you. Uh, A 21, 26, 36, 43, 44, 45, 46, 47, 42, 67, 71. Aniket Patil, what is your rule number? Why you not saved your number with rule number? Mr. Aniket Patil, are you there? Otherwise, I'll put it absent. Mr. Aniket Patil, respond me. Mr. Aniket Patil, am I audible? Or are you just logging? Yes, please. Okay, Aniket Patil and Rutuja Katkar. What is your rule number? Rutuja, Aniket Patil, Rutuja Katkar. Okay. Okay, fine, dear all students. Just you go through it, whatever today is I have to cover, and please increase your attendance strength. Okay. So if no students are there, then how we have to teach to whom? It's fine today. Okay, fine. You take for just 20 minutes study, whatever I covered it today. Okay, and you have to manage it. Thank you all.